We'll proceed in different coordinate system, and then we'll see that what is the use of different coordinate system as far as uh, separate usage and interoperability, something like calculating area, surface area, volume, and so many. If we have different coordinate system, then it should not add complexity. That is the main idea. So if I have different coordinate system, then it should not add complexity, rather than it should alleviate it, it should smoothen the problem. So solution should be easier if we have so many coordinate system rather than messing up with the coordinate system. What we have seen in the coordinate system, we have Cartesian coordinate, we have polar coordinate, we have cylindrical coordinate, and we have a spherical coordinate. If these are the coordinate system, then how it helps us in solving the problem? Okay, how it helps us in solving the problem? Let's talk about calculating the kind of curve length. We will start with that. Calculating the curve length. If I have, if I have, if I have a sphere, I really have a sphere. If I have a sphere and it is centered at origin, this sphere is centered at origin. There is origin. There, this sphere is centered. So if sphere is centered at origin, then along the x-axis, along the x-axis, there is a circumference. Along the y-axis, there is a circumference. Certainly, along the x-axis in the sense that this is x-axis, this is y-axis, this is z-axis. So in xz, if I cut it in xz plane, then there is a circle. If I cut it along yz plane, then there is a circle. Okay, any point at, if I take this beginning of the circle, if this is a circle, and here it is beginning of the circle along in xz plane, then how much is the curve length at any point x comma y? X comma y is said because this sphere has independent component as xy plane. Algebraic calculus works in independent component, dependent component, independent component, dependent component. So if it is a sphere, then it is three-dimensional. If it is a three-dimensional, this proves that there is a xy plane, and on the xy plane there are many x comma y points. If there are so many x comma y points on the xy plane, then against each x comma y point there is fxy, function over xy. That is also called z. What is that? So equation of a sphere is x square plus y square plus z square equal to a square. A is the radius inside the sphere. So z equal to a square minus x square minus y square square root, or function over x and y fxy equal to a square root of a square minus x square minus y square. If that is the case, then we have found the z formula. If this is the z, if this is the kind of a z formula, then what is the, if it is in xz plane, then what is the curve length from origin to any point x comma y? If I take xy plane, then any point x comma y it take, then it would result in fxy. At that position from the beginning, what is the curve length? Or I can say I want curve length of the full xyz, if I make a cross section in xyz, this is x axis, this is y axis, this is z axis, in xz plane, then there is a circle. In this circle, what is the full curve length? You can also call it perimeter. Okay, now if I take any point here, any point, if I take any point on the sphere from the origin, that point can be represented through position vector. That is xi plus yj plus zk. 3 points, that is 3D. So xi plus yj plus zk. Okay, if that is the case, then that would result in xi plus yj plus fxy function over xy, that is the zk. Whatever description we are giving, these may not be available anywhere repeatedly. So one disclosure we have found file, and that is available at medium.com /@ of meaning. That is the channel name. Remove the space, or meaning dot minhinc meaning.medium.com. If you go, you can see the recent most disclosure. We will have so many. There we have used partial derivative calculus in the cosine distance. We have used partial derivative in Euclidean distance also, that is anyway available. Cosine distance is new and it ours. Anyway, now if I have a position vector xi plus yj plus fxyk, then that is the position vector at any point on the sphere. If that is the position vector at any point on the sphere, then what is the curve length? So if this is the sphere, and this is z axis, I take any point here, that is xi plus yj plus zk, then from beginning, what is the curve length? That is the question. If I want curve length, then I have position vector. If I get velocity vector, so in calculus, if I have a velocity graph and if I integrate that velocity graph against the x-axis or the time, then I get the distance. So if person is walking 5 km per hour, that is the velocity graph, that is a constant. If I do 5 dt, that is against the time, then I can get how much distance traveled for any time. So if time is 4, then 5 dt, it would result in 5t integration from 0 to 4. That would result in 20. So he walked 20 kilometers. So if I have velocity equation, algebraic equation, and velocity algebraic equation, if I do integration, obviously against the time, then I get the distance. I have position vector. If I calculate velocity vector, and if I do integration, I'll get the distance. So that is the curve length. Curve length. Now the velocity vector is xi plus yj plus, this is Cartesian coordinate, and plus x fxy. If I calculate the velocity vector in the sense that partial derivative along x-axis, if this is the position vector, then velocity vector, that is partial derivative along x-axis, velocity vector along x-axis. I can do partial derivative along y-axis also. Let's calculate the circumference in xz plane. If that is the case, then it is, now if I differentiate with x-axis d position vector by dx, then it would result in I plus j is gone, I plus dfxy by dx k. So xi becomes I, yj becomes 0, and dfxy by dx k. So our velocity vector is I plus dfxy dx, that also called f dash, f dash or fx, small f, and at the bottom x, fx means dfxy by dx, partial derivative along x-axis. So fx. Now fxk. If this is the velocity vector, then what is its magnitude? That is 1 square plus fx square square root. That is its magnitude. Okay, if this is the magnitude, then what is this is magnitude of velocity. This is the velocity. So if velocity vector is v, and on top of this I place an arrow, v, on top of this I place an arrow equal to I plus fx k, this is the vector, then that is equal to unit vector, whatever I get the unit vector, into the amplitude of velocity vector. So this is the amplitude. Now I want the curve length, so I'll go for with the amplitude. At the end, I believe you people have kind of listened to me many times, football match and journey by aeroplane. If you're not, then you can watch past video. So football match and journey by aeroplane. So calculus at the end, whatever you do, it will bring it into algebraic equation. Because calculus is a game of algebra. So calculus understands algebra. It does not understand vector, whatever. So at the end, we bring the magnitude and we bring the net algebraic equation. That algebraic equation is magnitude of velocity. That is velocity. If I integrate along x-axis, then I get the curve length. So velocity vector is along x-axis because I differentiated partial derivative along x-axis. If I integrate it back the velocity amplitude, I get the curve length. Now the magnitude of velocity vector is 1 plus fx square, a square root, and then dx. That is the integration. What is dfxy by dx? What is the equation of a kind of a circle? If I have a circle, what is the equation? What is fxy? Dfxy by dx. What is fxy? In 3D, fxy, we said it is x square plus y square plus z square equal to a square. So fxy is 1 minus a square minus x square minus y square square root. If that is the case, then dfx by dx would result in, it is square root means 1 power 1 by 2. If I differentiate it, then it will become, I believe, minus x divided by a square minus x square minus y square. That is fx. Then partial derivative of function f along x-axis. If that is the case, now we have function fxy. Now, if that is the case, so the magnitude of the velocity, that is 1 square, 1, velocity vector is I plus fx k square root, where fx is derivative of function, partial derivative along x-axis. Now, the magnitude of this vector is 1 square plus fx square square root. Earlier it is I vector plus fx k vector. Magnitude is that much. So it would kind of result in 1 plus, now what is fx? 1 minus x divided by square root of 1 minus a square minus y square minus x square. Now, since we want in xz plane at the origin, so y is 0. Anyway, it is constant. So it results in 1 minus x, that is square, 1 square plus fx whole square. So that will result in 1 plus x square divided by a square root of 1 minus x square. Why I am setting it 0? Now if I a square minus 1 plus x square divided by square root of a square minus x square. The actual vector is I plus fx dfxy by dxk. Then velocity magnitude comes as position vector is xi plus yj plus fxyk. Velocity vector along, if I do the partial derivative along x-axis, then it results in I plus dfxy by dxk. The magnitude is 1 square plus dfxy by dx whole square square root. That would result in 1 1 plus x square divided by 1a square minus x square. Y square, y I have taken 0 because xz plane at origin I have taken. Now it would result in a square minus x square plus x square divided by a square minus x square. So a square divided by a square minus x square, full square root. So a by a square root of a square minus x square dx. Dx integration from minus a to plus a. That is the radius. So if it is hemisphere, if I take xz plane, then minus a to a would give the half of the circumference. Okay. Now what is the integration of square 1 a by square root of a square minus x square? If I go with the integration of 1 by a square minus x square, then it would result in sine inverse of x by a. Someone can prove it. So 1 by square root of a square minus x square dx, integration is sine inverse of x by a. Now I place limit minus a to a. If it is a, then it becomes sine inverse of 1, that is pi by 2. If it is minus a, then sine inverse of minus 1, that is minus pi by 2. Pi by 2 plus pi by 2, it results in pi. Outside a, pi a. So the circumference is pi a, half. Then I multiplied by 2, then it is 2 pi a. Perfect, right? So the circumference of a circle is 2 pi r. This is not the end. Okay, if I have a sphere and I cut xz plane at the origin, then it is pi 2 pi a is the circumference. What is the circumference if I cut in xz plane when y is 1? When y is 1. Okay, if that is the case, then we go back to the equation. The equation is now 1 square plus x square square root of a square minus x square minus y square. Now if I take this side, that side, it would result in now a square minus y square divided by a square root of a square minus y square minus x square. Now y is a. Y is a, not 1. Y is a. So a square minus y square result in 0. So there is no circumference. Certainly, right? If there is a sphere, and if I cut xz plane at the end, then there is only not even dot, nothing is there. So there is no circumference. What about circumference at any, if I cut it at any y equal to y? Anyone. I cut it at y equal to 2a, a 2a. Then how it will be? Now it is a square minus y square, square root of a square minus x square minus y square. So that will result in a square minus 4a square minus a square. Minus, it will go in minus now. So not possible. So this is not valid. Means a sphere is not there at y equal to 2a. Maximum y equal to a. Sphere is there. Okay. Now at any y, what would be the circumference? If I have a sphere, if I have a sphere, if I have a sphere, at the origin, if I cut xz plane, that is a full circle where y equal to 0. But if I cut little bit ahead where y equal to y, then what is the circumference? Circumference will keep decreasing till it reaches 0. If this is the ball, then at the center circumference is full. If I go more, I'll reach to a point where circumference is dot. There is no circumference. So in between at y, what is the circumference? That is a square minus y square divided in full root. A square minus y square divided by a square minus y square minus x square. That would result in a square root a square minus y square, where y is constant, and a square minus y square square root, and at the bottom we have variable x. Now here it is a square, here square root of a square minus y square square root whole square, I mean square root of a square minus y square minus x square. If it is 1 by square root of a square minus x square, the integration is sine inverse x by a. So here it will become square root of a square minus y square, that is a constant. I take it out, 1 by square root of a square minus y square minus x square. That will result in sine inverse of x by a square root of a square minus y square. Simple, right? So integration is sine inverse square root of a square minus y square into sine inverse of x by a square root of a square minus y square. Now I have to set x as minus a, x as, now x is x, if I take distance y, so let's take x as minus a, 2a. Now someone has to check this, minus a, 2a. So it will be sine inverse a by a square root of a square minus y square minus sine inverse of a square again, if I take minus a also. Sine inverse of x by a square root of a square minus y square minus a to a. Sine inverse of a divided by square root of a square minus y square minus sine inverse of minus a square root of a square minus y square. If I set y equal to 0, then it results in a and then sine inverse of 1 minus sine inverse of minus 1 in bracket. That will result in pi a. But if y is there, then it is a square minus y square square root, and in the bracket sine inverse a by a square root of a square minus y square minus sine inverse of minus a divided by square root of a square minus y square. Now keep changing the y and calculate it. It is not that difficult. A also keep some scalar value, then calculate the sine inverse from calculator, and you get the circumference at any. Amazing, right? Amazing. If I have this ball, if I have this ball sphere in my hand, and if I make a xz plane cut at the origin or at any y, if I make the cut, at that cut, what is the circumference that is in question? So this is the formula of circumference that is in question. Now let's calculate the surface area. Let's calculate the surface area. Now I have velocity vector. If I say dfxy, fxy is a function on x comma y, any point. So dfxy dx is the velocity vector that is along y-axis. dfxy by dy is the velocity vector along y-axis. Understood, right? So if what I'm trying to say is, if I have a velocity vector, if I have a magnitude of the velocity vector, and if I integrate it from origin, it gives me the length. Please understand it. So if I have, this is the circumference of a circle. If this is the beginning point, if I have a position vector at any point, if I calculate velocity vector from the position vector and take the magnitude of velocity vector and calculate the integration, it gives me curve length from the beginning. Don't go with the book. If you see in any book what I am going to talk now, every book, the best book also, they talk nonsense and rubbish. Delta I, then this vector, that vector, and this is infinitesimal small, and that is infinitesimal small, and then whatever we do. Those are, so probably I will place this as disclosure. If required, we will write a book also. Calculus is game of, not game of infinitesimal small. Calculus is pure game of algebra. It is algebra which takes care of infinitesimal small, not calculus. So calculus is pure way to calculate the area of the algebraic equation along a axis. That's it. Calculus is not more on it. That's it. So the algebraic equation takes care of infinitesimal small. what is the how many how many section, how many sampling I can take when x is 0.00001 to x is 0.0000001. If these two are the point in between, how many sampling I take, I can take in x-axis, infinite. So this is taken care of by algebra. The person who is doing the calculating the integration, he do not worry much about infinitesimal small and this and that. Just concentrate on calculating the area. Algebra takes care. So it's a layered approach, like in the calculus, in the nowadays deep learning is coming, where layer approach is there. So if you get the raw data from there, you try making the intelligence slowly, grouping the intelligence. Like if you have set of pixel, then you have to say this pixel contributes a human face or elephant face. Only the pixel, you will try to get something, then on based upon that, then again you try to get something. So these are called, the first is raw material, that is the physical data. On top of it, you start making abstract data, up, and then finally you will start getting nose, eye, cheek, and lip and forehead and hair separately. Then at the end you will assemble it and you will say it is human or elephant. So like that, integration sits upon algebra, give full pressure on the algebra. Whatever is there in the integration, that it does. Like if you see electronic circuit also, there is a layered approach. So one sits upon another, one sits. So at the base, very basic electronic circuit will be there. That will work for guaranteed. On top of it, the abstract, and then you get the electronic circuit. But you believe that everything is connected like a raw way, but it's not true. It's connected in abstract way, like TCP/IP layer in software. It's a raw layer, the most basic layer, and then you have on top of it you have IP layer, TCP layer. Then at the end you have, I believe, presentation layer. So everyone sits on top of the raw layer. Raw layer is the whatever is raw you have, okay, or data layer or whatever you call it. So like that, calculus is also there. At the end, only scalar data comes into the picture. On top of it, you get algebraic equation. On top of it, then integration. On top of it, there is differentiation sits on integration. So this is how calculus is also made. Now idea is that if I have a function fxy, if I calculate fxy dfxy by dx, then it is velocity vector along x-axis. If I calculate dfxy by dy, then it is velocity vector along y-axis. If I have these two velocity vector, if I have a velocity vector, if I have a position vector, from that if I calculate velocity vector, if I integrate, I saw we get the curve length. If I have a velocity vector dfxy by dy in that direction, then in yz, whatever is the curve length, that I get. But if I have a velocity vector along x-axis, velocity vector along y-axis, and if I do cross multiplication of these two vectors, then I get area in between rather than length. Cross product of two vectors gives the area in between. If two vectors, they make parallelogram shape, they are not perpendicular to each other. One is there and another makes an angle. It gives a parallelogram. If I do cross product, it gives area of the parallelogram. And the net vector, that resultant of cross product, is perpendicular to the surface of the two vectors. Okay. So now if I have a vector that is dfxy by dx and dfxy by 2 dy, these are two velocity vectors in orthogonal direction. If I do cross product, it gives me area. If I integrate that area, then I get the area from the beginning of the surface. This is the integration. If I do integration of algebraic equation, I get the area from the beginning. Keep changing the independent variable from the beginning. What is the area? You keep length. What is the integration area? You keep getting. Like if I have velocity vector along x-axis and y-axis, if I do cross product, it gives me area. If I calculate the magnitude of the cross product, that is the algebraic equation. Now if I integrate it, then if I integrate it, okay, I repeat it. So if I have a velocity vector along x-axis I have a velocity vector along y-axis. If I do cross product, then I get the area velocity vector. Area velocity vector. If I calculate the magnitude of velocity vector, then it comes in area algebraic velocity. If I integrate it, then I get the area. That area, if I keep changing the independent variable, then from beginning it gives me the area. If that the if I want full surface, then I have to place the limit from beginning back to the beginning, or beginning to the half and double it. Understood, right? That's why I gave example. The idea was to calculate the area. But beginning I started with the curve length. If I started with the curve length, then how I can calculate the area? Velocity vector along one direction, velocity vector along another direction. If I do cross product, I get a velocity kind of area vector. If I do the calculate the magnitude, then velocity area magnitude. If I do integration of that that amplitude or that magnitude of the cross product, then I get the area from the beginning. Keep changing the independent variable, you keep getting the bigger area. Place the limit from 2 and you get the half of the sphere. That is the idea. There is nothing like, if you see in any book, they will take one delta x, delta y, and this axis, that axis. Consider this is a parallelogram, and nonsense. Okay, so we will place this as disclosure because people are going in wrong direction in as far as calculus is concerned. Don't make anything complicated, unnecessary. Okay, so best technology is technology which is simple and it is layered by, it is sitting on top of each other. Do your work and pass it to the next layer. Why you are worried? So if I am now, what we are doing is we have algebra on top we are using vector, and on top of vector we using the kind of calculus or whatever. So if I have velocity vector 2, then I calculate the cross, then I get the velocity area vector, kind of that surface vector. If I calculate the magnitude of velocity surface and do the integration, I get the net area. That net area is again is a algebraic equation in independent component x and y. Keep changing it, you get the bigger area, the way we did in the curve length. So curve length, what we received was a sine inverse of x by a. That is the algebraic equation. So keep changing a and limit means keep changing x and you get the curve. Okay, so what is the curve length at when x is 0? Sine inverse of 0 is 0. There is no curve length. When x is 0, there is no curve length. What is curve length when x is half? Then sine inverse of half by a. A would be something. Then, okay, so no need to place limit also, 0 to 0.5. So keep changing and get the curve length. This way, we will calculate the algebraic equation of area velocity. And if I integrate the net area, I'll get in algebraic equation. Keep changing x and y, keep getting different area. Place a limit, one place to another place, you get the area. From 0 to other half surface area, you will get multiply by 2, or if you get 0 back to the 0 or 2 pi. Okay, so this is the fundamental of calculating the surface area. Now let's proceed calculating the surface area. Now if I have dfxy, what is the position vector, that is xi plus yj plus fxy k? Then what is the velocity vector along x-axis, partial derivative? Dfxy dp by dx. If this is the position vector, then dp by dx, that will result in I plus fxy fxk. Another is dp by dy, that is j plus fyk. If I do cross product of these two, then they would result in minus fy. Means I remember it. I am not calculating now. Minus fy, partial derivative along y-axis, minus fyi minus fxj plus k. Okay, if I calculate the magnitude, it would result in net 1 square plus fx square plus fy square. So this is the net velocity area. If I do the integration along the xy plane, then I get the net area as algebraic equation. Algebraic equation takes care of the infinitesimal small. Okay, if you're dealing in vector, deal in vector. If you're dealing in algebraic equation, deal in algebraic. If you're dealing in integration, deal in integration. If you're dealing in differential equation, deal in differential equation. Don't do infinitesimal small and there and make an assumption that it is very small, so it will be perpendicular and then it will stay. Don't do like this. Where just think that at what layer you are sitting. At that layer, according to that layer protocol, according to that layer, mathematics do the computation, pass it to the next layer. That is the science. Now I have velocity area magnitude, that is fx square 1 square plus fx square plus fy square. Fx is partial derivative along x-axis, fy is partial derivative along y-axis, square. Now 1 plus fx is dfxy by dx. So that is, now what is fxy? That is a square minus x square minus y square square root. If that is the case, then we have now 1 plus x square divided by 1 minus a square minus x square minus y square plus y square divided by a square minus x square minus y square. Now at the end, if we do here and there, it will result in a square divided by a square minus x square minus y square whole square root. That would result in a by square root of a square minus x square minus y square. Now we have to integrate with the surface area, that is xy plane, that is d of the xy plane. D of the xy plane result in dx dy. So I have to integrate. So if I am calculating a surface area, then x is varying minus a to a, y is varying minus a to a. Double integration minus a to a minus a by square root of a square minus x square minus y square dx dy. Okay, now if someone has really guts, you think that y is constant when we calculate the dx. We consider y as constant when we calculate the dx. If that is the case, then it would result in sine inverse x by a square root of a square minus y square. Limit is minus a to a. Whatever comes, then that I have to again integrate with the y. Considering now x is anyway gone, if I place limit, and then again place the limit minus a to a. Okay, that is half hemisphere. That should come as, I believe, what is 2 pi a square or something like that, because full is 4 pi a square. So that would result in 2 pi a square. So that is the kind of questionnaire, that what is the integration of a by square root of a square minus y square minus x square dx dy, where limit is minus a to a and again minus a to a. Okay, that would result in sine inverse of x, sine inverse of x by square root of a square. So top is a by, so a sine inverse of x by square root of a square minus y square. Whatever comes as the, okay, okay, so this, if I do the integration against dx, then that is, now a is a constant that remains, I take it out. So 1 by a square root of a square minus y square minus x square dx, the integration comes in sine inverse x by square root of a square minus y square. Now limit is minus a to a. Whatever comes in, it will come in term of a and y. Whatever comes in, again integrate with dy and then place the limit minus a to a and you are done. It should come, I believe, somewhere as 2 pi a. A is outside, then 2 pi a square, something like that. then double it, 4 pi a square should be the kind of area, surface area of a sphere. Now here, this is the one approach. Second approach is hybrid model. Hybrid model where we think about polar coordinate, a spherical coordinate, pushing in this calculation. Why we can push polar coordinate here? That is the question. We are integrating a algebraic equation, that is a by square root of a square minus x square minus y square with d of xy plane. D of xy plane, that is in Cartesian coordinate it is dx dy. But we can, if it is d of xy plane, if I have a sphere, and a sphere, if I make a cross section of the xy, if it is centric on the origin sphere, if I make a cross section at the origin, then it would result in a circular region, okay, with radius minus a to a and minus a to a in xy. So it is xy plane. If I make a cross section, xy cross section, then it would result in a circle. If it results in a circle, then dA, the integrating, the dA is nothing but circular region. D of xy plane in circular region. If that is true, then the in circular region dA can be replaced in polar coordinate as r d theta dr. That we will talk. This is hybrid model. Can you see this? Full we started with the algebraic equation, Cartesian coordinate. Now the algebra, what we have, a by a square root of a square minus x square minus y square, or a square minus y square minus x square. That is Cartesian coordinate d of xy plane. Now xy plane, we can, it is a circular region, so we can change it to polar coordinate, and then life will be far easy now. So this is alloy, this is hybrid model, this is interoperability, through which, so limit would change, because now limit we have placed minus 1 and minus a to a minus a to a, that is in Cartesian coordinate, that we will convert into the polar coordinate. But the point where it we saw hybridization, because we saw we are calculating integration d, not dx dy, d of xy plane. D of xy plane is a circular region, so I can convert into polar coordinate. So that's where other coordinate comes into the picture. So that we will see. But the questionnaire today is, can we calculate directly into Cartesian? Is there someone who is so powerful in calculus algebra, then he can calculate a by square root of a square minus y square minus x square dx dy, integration minus a to a, integration minus a to a. If I keep a outside, then it becomes 1 by square root of a square minus y square minus x square dx dy. First integration would result in sine inverse of x divided by square root of a square minus y square. Limit is minus a to a. Whatever comes, that is a and y. In a and y, a is constant, y is variable. Again integrate with dy. Whatever comes, place minus a to a. So this is the questionnaire that has to be solved. So now we will start seeing interoperability in different coordinate system in calculus.